we're going to go ahead and get started with our webinar, Continuous Delivery of Stateful Applications with Kubernetes in Production. We're proud to welcome our stateful application expert and the original Kubernetes product manager, Eric Han from Portworx. And we have CodeFresh's very own full stack engineer, Kubernaut, and our Vice President of Marketing, Dan Garfield. So let's go ahead and get Dan and Eric on here, and we'll get started in just a second.
Yep. All right. So everybody should be able to see and hear us. I'm seeing some nods from the moderators. Good. Excellent. So thanks for waiting for that. I lost the Zoom controls. So I'm Dan Garfield, as Taryn said, and thank you for that wonderful introduction. I work for CodeFresh. I'm sort of our chief evangelist, and CodeFresh has been around for a couple of years, and we've built over 3.5 million images and are kind of all over the place with customers from, ARM, the huge chip designer, Giphy, serving the most important GIFs on the internet. So we have kind of this eclectic, interesting customer base, but they're all sort of joined together by the common theme of they're using Kubernetes, they're using containers, and that's really our whole focus. And preparing this was a lot of fun because I had Eric with me. And so Eric, I want to introduce you and let you maybe say a few words about yourself. But Eric was the original Kubernetes product manager and just incredibly sharp. And coming into this, I was new to Stateful and had been at, spoken at lots of different meetups and events and things. And people always asked me about Stateful services. And I always kind of had to punt because I didn't have really great answers. And so in working with Eric, I was able to get a lot more information and actually learn a ton from you. So I really appreciate it. And it's been a lot of fun preparing this. I think we have a really cool demo and I'm really excited to share this. But anyway, Eric, let me go ahead and introduce yourself.
Well, first of all, thank you, Taryn and Dan. It has been fun, and you presented at Portworx sometime in the fall last year, and we've known CodeFresh for quite some time, going back to several KubeCons as well as DockerCons. So it's been great to watch CodeFresh and work together, and now get to the point where we can show something unified between Portworx and CodeFresh. So I think there's a lot more going forward. And so I love the demos you've given. I've talked to everyone about your Mario demo, and I've been envious, and I got to figure out how you did it. So thank you. And yeah, I think from our perspective at Portworx, we're here really in the sense that we see everyone wanting to be able to move to this containerized portion. And a lot of the value comes when you can do it with the stateful application. So happy to be here, spend some time talking about what people are doing in the ecosystem, how it matters, how it impacts them, and then just a little bit about how Portworx addresses that problem set. And then end with something that's really cool between Portworx and CodeFresh.
Yeah, thank you. And with that, I also will mention that some of the underlying technology we're using here that's really interesting and cool. We decided to use GKE, Google Cloud, for all of all the clusters here. Really lovely to work with, just a joy. So anyway, and we'll see that later on. But today what we're going to cover is basically an intro to stateful applications. We'll talk a little bit about best practices and how to approach and work with stateful applications, both in production and staging, how it works inside of Kubernetes. And then we'll talk about sort of functional testing with data and continuous delivering with data and how that sort of works. And then we'll have some demos and we'll do some Q&A. So with that said, I think Taryn introduced everybody to the Q&A button. Feel free to ask questions there. You're welcome to use the chat, though if you use the chat, lots of times I won't see the questions at the end and can't mark them as answered. So if you use the Q&A, you have a better chance of having your questions answered. This is being recorded. We will have a copy of this available afterwards, as well as the slides, so you'll be able to review it and share it with your team. But obviously, if you want to run them into the room, and that's my preference. So with that, Eric, why don't you take it away?
My pleasure. So I think one thing I'll start with is a lot of people ask, when does stateful and when does stateful matter and what's the evolution? And I think one key thing is, and this is some of our conversation, Dan, is that I think every application has state. The only stateless application that I've seen, and credit goes to Robert from Cumulus for this comment, but the only stateless application out there is really Hello World. So if I look at the stacks, there is a separation between stateful and stateless stacks. So in some ways, this is a simplified breakdown. But when I look at it, the important thing or what strikes me is that customers are already starting to do this, or users are already starting to do it. And it's important because the apps that they're building, they have to be interactive, they have to be real time, or they have to service some business need where they can't predict what the stack is going to be. So it's going to be that the developers want to use Couchbase or Cassandra, and they're going to pick it off, and they want off-the-shelf components. They want to download it from a registry and be able to run. And suddenly infrastructure people, the users that run Portworx, are saying, like, how do I manage? How do I protect the data? And that's where we come in. But if I talk about what stateful and stateless means, I'll just use a simplified filter to say, like, on the stateless side, there are things like Nginx, Ubuntu, Debian, and they may be traditionally thought of as, hey, a replication controller or some form of HA can just spin it up, and it's okay if data's not there anymore. And so that's an oversimplification, but it starts to separate the world into that. There are the stateful side where it does matter that I have the data intact, and we'll talk about the underlying elements like PVCs and persistent volumes and how those all matter in a scale-out cluster. But the simple thing is, am I building applications, or is my team wanting to build applications and they're running MySQL, Postgres, and things like GitLabs run over Postgres? And then if I look at CodeFresh, your pipeline has state, and every user has to be protected in terms of their state. So people are wanting to do Elasticsearch clusters, and they start to build search analytics. So all these things matter because the business needs them. And now what do I do? And we'll talk a little bit about just the generic pitfalls. We'll make it across all the industry. But let me just start and back up a little bit before state. And this is actually more from my personal experience. Before I worked at Google, there was a time where I was actually the Zune Web Services product manager. And I
had a Zune, by the way.
You had a Zune.
Oh my gosh, it was sweet. I love that thing.
There's more Zunes in my house than there are people in my house. My kids each have 2 Zunes. So I'm an even bigger fan, Dan. The thing, and Zunes come back in vogue because of Guardians of the Galaxy at the end, where the hero gets a Zune.
Yeah.
But if I look at Zune and how we were building, it was a different era. We're talking 9-10 years ago. And the funny thing is, like, Zune happened when my first child was born. I remember my wife is like, our baby was a week old. I was going back into the office because we were going to do a deployment. And we we're basically going to launch the second version of Zune Web Services. And at the time, the way our app looked was really that it had every application owned its own server. And you can say Cassandra does it today, or Cassandra likes to do it today, or Mongo, and that's true. But back in 10 years ago, it would look like this. You'd have a web server, you'd have a couple sites on it, and then have a business tier, a middle logic layer, and then connect into, at that time, SQL Server. But these things were very manual in terms of, we had build systems, but the process and the decision-making was completely manual, unlike what we have today with CodeFresh. And the density that people want were very minimal. They wanted one application to that server. And what that really led to, in some ways, is the idea that, the world's different now. I have containers, I have build systems like CodeFresh, and I also want to be able to create a lot denser set of applications and have variety. But the reason I need to is because, going back to that Zune experience, we were really rigid and our scalability was very poor, and it led to very high costs per application. If I thought about the amount of manual time and the amount of resources I was spending, it was extremely expensive. And so the upshot of that story is, my daughter was a week old, my oldest child. I told my wife, I'm going to go in the office, we're going to deploy, it's going to be a couple hours. It ended up being a 5-day deployment. And so, I wasn't earning any points back home, especially with the firstborn. But the idea here is that we didn't have this continuous process of how to monitor, manage, and the world's a lot better now. And so, what does the world look like today? Forget, my little story. But the world looks like, if I talk to my customers, what they're trying to do is they're trying to build clusters. It could look like a pipeline. This is a simplified pipeline. And the reason they're doing it is because they have things like Kafka that can handle large amount of processing, and they're using Cassandra for caching, and they could throw in Spark or other things. But the idea is that it's going to be dynamic. It's going to be dynamic because the users and the use cases, it's not one site that gets the whole hardware. It's many users saying, I want to come in at this point. These are sites doing flash sales. These are sites doing just internal IT hosting. And the developers also want to change the mix. So the demand is changing, the mix of applications is changing. And it's no longer, I want to go procure a server to then deploy this app. Instead, it's, I want to procure a container. And how quickly can I procure a container and offer it to my developers and then offer that hosting to my developers and offer that to the business? That's the name of the game. And that gives me some agility here and in the competitive ecosystem. So people are creating 20 containers per server, and some are doing 40 and some are doing 90. And what that means is that I can suddenly have a lot more agility, a lot more density. And so no longer am I in this world where it's manual. It's much more automated from both deployment, and that's why we have Kubernetes. It's automated from a pipeline perspective. That's why CodeFresh is super important. And what it leads to is lower costs per application in the whole entire process. And it also requires faster delivery, faster delivery requires continuous integration and testing. So the whole thing is this all fits together, right? I don't want to be in the world 10 years ago where I can't tell if I'm going to come home that night because production is something that is very manual. Every application gets its own server. Instead, I'm now at a point where I require automation. I want the whole pipeline to help me make higher level decisions. And the things like managing bin packing or managing how many containers per server, Kubernetes will help me. And I need storage systems that handle the data. And that's where we come in. And this is still very much at the point of view. Let me just talk about the market and what people are doing. And if I think about it, what's the beauty of Kubernetes? It really gives me this idea that I have an application definition and it's portable. If I look at this picture, what I'm drawing here is that there's a pod, and that pod is basically running, and it's running with a database. And actually, this is a typo. It should be the pod itself is a Postgres pod, but the PVC is correct. The PVC is saying, hey, I want to have a persistent volume claim for my production volume. And what this taupe layer is really saying is this is all portable. If you look at the Kubernetes.io page and you look at the best practices, its whole point is these specs have to be completely defined in a way that I can run on any infrastructure. So I basically want to be able to take the best mix of applications, Postgres, MySQL, Mongo, bring them down, create the definition, let my developers run with that. And at the same time, I need a layer that marries me or bridges me to the infrastructure because I do have to run on some piece of virtual hardware. And what that ends up looking like is this bottom layer. And this bottom layer is where storage starts to come in. So more from the perspective of, regardless of what system you choose, what environment, Portworx, not Portworx, AWS, bare metal, it all will look something like this. I'll always have an application definition. It'll always talk about the PVC or where I want to get storage. And that's PVC is really a ticket. That ticket says, I get to have this piece of storage. But that PVC will also reference things like storage class. And I'll show you, or I'll show the ones that we use. But those storage classes are really saying, hey, this is what my infrastructure needs or offers. And it could be things like highly available storage, replicated, it could be encryption. And those matter to the business because when I'm running these applications, I want a way to offer the best of the infrastructure, but still have these portable application definitions. And that storage class will tie me to a persistent volume. And what it really is saying that when this all works together, applications are launching, Kubernetes is scheduling them. It's scheduling them based on what kind of requirements the storage is offering up. And then from there, it can run and the infrastructure can say, here's your encrypted, highly available volume. Now, the thing that we do at Portworx that's a little different is we're trying to make sure that that volume itself is multi-cluster and portable in a secure context. And what that really means is we're doing things like high availability across nodes, ensuring that you can have higher density. So one EBS gets recarved by Portworx to many users, and I'll show that in a second. So there is a little different spin that every infrastructure provider offers. But at the end of the day, one question you asked me is it as simple as an application pod saying, I need a piece of storage through PVC and getting it from a persistent volume? It is. And then from there, every infrastructure provider can say, this is the market I want to serve. I want to serve multi-cloud customers. I want to serve the idea that I can back up and have my data be portable, just like Kubernetes pods are portable. So that's where everyone gets to innovate in a sense. But the common user experience is very much driven from the fact that I can Kubernetes cuddle and express all these points from the application down to how you install Portworx.
Well, and this goes back a little bit to the point earlier you made about because we can define this, we have a lot more confidence and a lot more portability and a lot less headache around something like a deploy. We can say, look, I can, because this is portable, because it's defined, I basically have this infrastructure as code component, I can spin stuff up on demand. So why would I be worried about whether or not I'm going to be able to update? Because the abstraction layer is large enough that it's convenient to work with.
You're absolutely right. Actually, you pointed out something that I should have mentioned in my story is that, in the Zune days with Microsoft, we didn't have this declarative deployment. We had scripts imperative, I understand that, but the point is that we couldn't say that it's repeatable, it's guaranteed, and it's predictable. No. And so you hit the main point is that in all this world, everything is declared, and so I can declare what I want my volume behavior to be. And it helps me have confidence and roll out. And it also helps just the whole entire flow. So thank you for that. Just to show you what that looks like is that if I drew it out, and this time I named it correctly, the pod itself is Postgres. It will still take a container, and this is generic, and this is in the sense that in a Kubernetes pod, the type I have it that it's a pod, I have that I'm using a container Postgres, and it has a mount. And so Postgres itself, when it runs in Kubernetes, it'll say, where's my data get written to, and it's mounted at a mount path. And so inside the container, it's var lib, it's actually Postgres data, and then I can write my data there. Now, where that data actually lands is where that whole entire persistent volume claimed process starts to happen. And so in this case, I've given it a PVC. That PVC, I'm just pointing out that PVC is trying to identify a volume, so I gave it a cute name that the claim name is seeking volumes. But that PVC is my ticket to say, how do I get a piece of storage that looks like this? And in this case, the PVC that I want for my Postgres is going to be 8 gigabytes. I happen to say the storage class name, and that's important because that's where I get to take advantage of the infrastructure provider's properties. And so here I'm saying I want a Portworx or PX highly available. And then that will map to a separate piece of spec or YAML, and that storage class gets instantiated, and it says, here I named it Portworx, and I define the file system I want. So Postgres, if I want, there's a debate between Postgres, does it want XFS or ext4. From a Portworx perspective, we offer block, and this is where we can just basically say that block storage then gets ext4 or XFS.
Yeah, you can
ask for it.
Yeah.
And so from that perspective, IO priority high is just saying, like, if I have multiple classes of storage, how do I land on the appropriate piece of storage? And then replication is saying I want it to be replicated across clusters, or across racks. And then in the end is what you get back. I know I skipped step 3, and I'll talk about that in a second, but step 4 is basically when the whole cycle is complete, you get back a PV. So an application on the left in red says, I'm Postgres. I want to use a volume. It identifies the PVC of the ticket the ticket in yellow, and that's part 2. And it says, I want to have a persistent volume of this space in this class. And the storage class then defines for every infrastructure provider what's the properties it wants to offer up. So everyone else can provide a different storage class. Ours happens to sit on top of EBS or Google's persistent disk, or on top of bare metal or VMs. And so that's what we do. But others can offer it, they could just offer you EBS if they want, right? And that's that choice. And then the persistent volume that you get back meets that spec, and that's where you actually write your data. The step 3 that I skipped over is really that there's a piece underneath the covers, which is all having to do with what Kubernetes is doing from a storage driver perspective. And there's a lot of things evolving there very nicely, both in the form of in-tree and out-of-tree drivers. And that helps do the whole tie-in, but that's not defined in the YAML. So I'm just identifying a placeholder for there. But what this means is I can take this pod, and with very minimal any kind of configuration changes, I'm taking this pod and I'm running it anywhere I want. And I'm able to take advantage of the best kinds of things that my infrastructure is providing. And at that point, I get to innovate there, and application owners get to have this portability at the same time. And that's really important in this space. And so let me just mention a few of the things that people run into in sense of best practices. I think, if I talk to customers and I talk to users and say, where are you? Where do you want to be? I think what ends up happening is that they already understand that it's not like the old days where one application owns the whole entire server. So it ends up that many applications want to be able to run on a server. It goes from an economics point of view, but if I look at even a Kubernetes definition, the moment I run a pod, pods have multiple containers in them by definition, or can. And at that point, I'm already multi-container per server. And so from that perspective, I also want to be able to treat my servers as a piece of infrastructure that is, in some ways, cattle, if you want to use that analogy. But the point of view is that if I want to upgrade, you mentioned immutable infrastructure. If I want to patch the kernel, if I want to upgrade some host level system, I don't want to think about that server only does one thing. I want to think about that server, if it dies or if it needs to update, I can manage it easily. I can take all the applications, move them off like I would a stateless. I can go patch the kernel because there's some Spectre or meltdown issue that I need to address, and I can restore it. And that is where people are trying to get to from an infrastructure level, but from an application developer, they just want to run their apps.
Right.
And Kubernetes already says multiple containers in a pod, and then I'm going to run multiple pods. I want to run multiple pods per server. And so that's what I'm drawing. And I only draw 2 boxes per server, but you can imagine that there are 90, right? Or there's up to 100 actually. And at that point, what ends up being my concern is that if I put that on top of an array piece of storage like Amazon EBS, there's things like stuck mounts, but even before I get to stuck mounts, the question is, how do I make sure that I can let Kubernetes run me on another server if that EBS gets stuck or if I have some failure? And if it's on-prem, it's even more of a concern. So really, the point number 1 is, and that's what the red cylinder is illustrating, is if I have a failed mount or if I have something where I need to fail over, I want to be able to let Kubernetes say, spin me up on that next server, and my data is already there. So people really, for these relational systems, want high availability. And it actually ends up happening with Kafka as well, is that, Kafka and all these sharded systems, they also want the ability to say, run on any server and take advantage of something where I can start. If you look at Amazon's best practices here, it's oftentimes take advantage of EBS so I can start from some known state. But the point I move to containers, I can't take EBS with me because if multiple applications are running on that EBS, it's not per application anymore. Mm-hmm. And if I give it to a Kafka broker, suddenly I have everyone else's data. That's not useful, right? So what I really want to say is that if I fail over or if I have an EBS issue, I want to run with Kafka. And even though it's a sharded system, I want to start from a known good state. So I don't take down the whole entire cluster, rebuilding my whole entire Kafka topics. So the stuck without HA applies to both relational and sharded systems. The data protection, this is independent of any storage provider, is really that people want to be able to snapshot backup. So there's a lot of things coming, and you'll actually demo it in your demo in a second. But the thing here is that soon this will be available to everyone, is people want to be able to snapshot and then back it up, but how do I restore it? And how do I do it in the sense that I no longer can rely on the VMDK in a VMware world or EBS to do so, because I am running dense multiple containers or pods per server. And then performance control, and now we're starting to get to, like, if I thought about it, what are people doing? These inventory systems, these super important, mission critical, business critical, they need to be able to say that there's some of these applications are scratch or less important. Some of these applications are part of my front end serving. So I'll give those guys priority, be able to tune it, and it has to be declarative. And so that's where
otherwise it's not reproducible.
It's not reproducible, and it also becomes like, hey, something happened in the middle of the night. What do I do? And that's another evolution of the reproducibility, right? And so I know I'm throwing a bunch of stuff. I don't want to say that, you can't make a right, you can't make a left. There's a lot of concepts. It's actually more just a lot of fun things, but it's stateful containers. Are they hard? Persistent volume claims. What happens when I do dozens of apps? The answer here is that there might be some conservation of complexity, but as infrastructure providers or technology providers like us, we're trying to absorb that. So when people ask me, is it hard to do this? I think it's straightforward to do this from a demonstration. And this is where, from our perspective, we're trying at Portworx to leverage all of our customer experience and bring it together and give you a solution that takes the best practices, puts it in, and provides that data persistence layer that manages the lifecycle. So I'll go into what that means.
There's a certain amount of abstraction that I think, and part of what I think we're trying to do here is show a little bit about what's going on behind the scenes so that people can feel comfortable and confident that it's going to work the way they want it to work. We already deal with a lot of abstraction and technology, right? Like, we don't have to worry about the physics of how electrons move between circuits because it's so far down the stack that it's just not a concern for us. But we have a reasonable certainty that it's going to work every time, and we don't need to worry about that. And that's sort of the state that I think we're getting to with Kubernetes and some of the stateful work that's done here, where I can declare PVC, and I can declare this, and I can declare that, and the cloud provider is going to, in essence, do the work.
You're absolutely right. Actually, if you look at my prior slides, I was actually showing the sausage making. Yeah. Right. So do people want to just consume it, or they want to know how the sausage is made? And just in the sense of, it's a lot of fun to look at the technology. I want to show how the sausage is made and how the components are built. Yeah. But in terms of just consuming it, that's what I'll show in a second. But you're right. The abstractions are there, and it helps me ensure that I'm not only taking advantage of the right abstractions, but the whole entire community around this.
And for me, coming out of new, it's at the level where, like, I can execute one of these sort of high level, like, give me a persistent volume, here's the class that I want to use, and it feels like a superpower because it's like, well, that was magic. It just works. That was neato.
Well, that's a great, that's the best endorsement possible. So I'll actually rifle through this really quickly because I think, I want to get to the demo because that's probably more powerful. I'll just explain quickly how we do it, and it'll just be 30 seconds per slide, and these slides will be available. But from a Portworx perspective, we are a software-defined storage layer. That's actually a classically known term. The only difference is we built it for containers. So that means that every time a volume gets created, if it's a volume, it's actually for a specific container. And that's analogous to the fact that we're isolating storage, but we're just isolating it for containers. So people have done it for VMs, but it's very different to do it for containers because now the abstraction or the HA patterns or things like sidecar are different. So I can't say that a VM analogy works anymore. I have to think about what Kubernetes has done to the distributed system. And so from that perspective, our unit of granularity is a container, but from a device physics, we do things like aggregation. So elasticity is just saying, if you have a couple disks, we'll aggregate those, we'll understand that this is fast, this is slow, we'll actually start to watch it for health, and then we'll aggregate it not just on a single node, but across all the nodes. So it is an aggregation technology. It does allow me to pool and also understand how drives are working. And that's important because people want to know that somebody's managing it for them. And that's what we do, right? And afterwards, all those volumes that are container granular, we have HA for each container if you wanted to, or each volume. And so that's container granular HA. And the last point is really that the control is unified. So the control is unified through our command line or our RESTful API, but also Kubernetes. So what you probably saw is I could just launch and I can do all these experiences, PVCs, PVs, snapshots. And that's the idea that I can control it across the whole entire cluster. So you no longer have this idea of this server can only run this app. Every server can now run any app. And it's important from both a operations, but also from an agility point of view. But what ends up happening is that it's not enough to be a storage layer. You also have to integrate into Kubernetes. And so the things that we do is that we help give signals back so that when Kubernetes schedules a pod, it can say, land on this server, because that's where the data is. If I want that, if I want to be able to be local or hyper-converged, to use jargon, but I want to say that Cassandra application can run on the server that's appropriate, that has a replica of the data, including on failover, or I should avoid the server because the server has storage that's dying. So those are things that we integrate so that you have to have storage, but you have to have this orchestration integration. And the last thing that we do is we're really there to help manage the whole lifecycle, snapshots, backup. And so what we support is the fact that you can take KMS systems and you can take things like Vault, Docker secrets, or Kubernetes secrets, and then we'll start to do the encryption. So this is part of the lifecycle of data, is that we'll encrypt the data. We actually take two keys, one's for primary data and one's for backup, because oftentimes the backup administrator is on a different set of clusters or manages a greater scope of clusters. And so what ends up happening is that you own the keys, we encrypt. This helps reduce your risk. It helps with things like PCI, HIPAA, if that's part of your policy. And then afterwards, we do things like on a schedule, back it up to object storage. But you can see how this builds multi-cloud patterns because I can do it from on-prem to AWS, and I can do it in reverse. So that's just quickly how we do it. It's not the only thing, but I just want to give a high level. And I think the more important thing is that, at least for this audience, is especially what we're doing together. So I'll describe a little of this, and then actually, Dan, maybe you want to take over as well, is that I think what we have together in terms of what we're showing actually helps build future patterns, but it's the idea that I have Kubernetes, it has stateful applications already, and I have Portworx, and it provides me the volumes, and those volumes can be sitting on GKE. And so on GKE, I'll have a Portworx volume that is actually sharded across, or it's actually consumed on a disk, PD, but I could have many Portworx volumes on that single PD. And it's replicating across the availability zones, because when you ask me what's another best practice in public cloud, all the cloud SLAs are written per availability zone. And so you don't want to get into a situation where my stateful applications randomly all get sent to one availability zone. Instead, I want to solve that PVC zonality problem. And I want to be able to say that any application can run on any availability zone because that's the SLA. And I want to be able to recover it in an AZ. So I'll basically have an AZ split this whole thing, or we can have an AZ split this whole thing. And from a replication point of view, you can have that your data is in this AZ and it's also in that AZ. But from the whole entire stack, what ends up happening is Kubernetes is running the application part, providing the volume and sitting on PD. And then the continuous delivery is the part where CodeFresh is able to orchestrate this whole thing from a process point of view or pipeline point of view.
Yeah, so this is like the sort of brass tacks of like, okay, cool. Like we've got this storage class, we've got this storage layer, we can move data around. What does this give us? Well, I mean, beyond just the sort of reliability standpoint and the sort of sysadmin stuff of like, oh, cool, I can create backups, I can restore them, I have high confidence that my configuration is going to work. But one of the things we can do to bring it over to the application engineers is we can actually, because creating a snapshot is trivial, I can take production data, load it into a staging instance, run all my functional testing that I want to do, you know, security testing, UI testing, whatever, performance testing even. And then I have such better data because it's almost like a blue-green deployment, but we just get to test like the blue part and we can tear it down when we're done. So it's really a high degree of confidence. And, you know, I actually worked with a company last year who was really, really proud that they could take production data and use it to test with. Yeah. And it was a fairly Herculean effort to make it happen and make it work. And we set this up in like a couple hours because it's changed. It's changed that much. So this was really cool. And so to introduce, I think this is actually the part where we should introduce the application we're going to be working with today. This is an application that's called a voting app. It's pretty familiar to those in the container community. But basically, you've got this nice polyglot kind of architecture. You've got Python in here. You've got Node. And then our persistent, we also have a .NET worker in the back end. And then we have this Redis instance that's sort of acting as a messaging queue. So I can have, I could potentially scale up that voting app, that Python app, so that I could have, you know, millions of people all voting at the same time. Redis is handling a queue that's giving work to the .NET to actually get things into Postgres. And then Postgres is rolling that back into the result application so people can actually see what's going on. And the kind of component of this is that, of course, each of these things, they're running inside their own container. They can actually all have their, you know, different scale to them. So the voting app, like I said, could have dozens of containers, and we, you know, you could have lots of workers, we could have lots of node elements, and they can kind of scale independently. And this is one of the promises and joys of Kubernetes. And so to help us do this, we're actually going to use a technology called Helm. And I'm not sure from the audience how many people are familiar with Helm, but it's a really critical emerging technology in Kubernetes that's now being used in production by quite a few large companies, large organizations. And basically what it lets you do is package applications for Kubernetes. So rather than, you know, to deploy a single container, you might have a deployment YAML, you might have a service YAML, you might have a PVC YAML, you might have you know, several YAMLs that are associated with it. And so Helm basically lets me say, well, I can package all that stuff into kind of a block, and I can say, if I want to deploy this Python application, well, it really relies on all these other elements here. So I can build my containers that are my code, and I can pull in these Redis, Postgres instances, which are basically generic, which are basically the official release packages. And I can just pass in some values to that package, and it will execute with those values in the configuration that I would like. And again, the whole thing is declarative. That's the whole point of this Helm thing, is basically to kind of supercharge the declarative nature of Kubernetes and make it manageable for these complex applications where you have lots of microservices interacting.
And just to jump in, we've seen it with a lot of our users as well, because they want to be able to version and say, this is the deployment, or this is a whole entire package that I'm deploying, and then I'm going to make sure I know it's good, and then I need to have that versioned in some way. And that's what Helm also gives me.
Yeah. And we'll see some of this in the demo. So again, as we go along, feel free to add questions in the Q&A. And this is the delivery pipeline that we're going to execute on. So for this application, what I'll do is I'll make a change, probably to the voting app. I could make it to the result app. It doesn't really matter where I'm making the change. This is one of the joys of abstraction, right? I'm going to make the change, I think, to the voting app, and then I'll commit that, and it could be a commit on GitHub or GitLab or Bitbucket. It doesn't really matter, but the commit is going to fire off a webhook into CodeFresh. And what we'll do is we'll build all the images, and we'll build our chart at the same time. And then we'll actually clone that live data. Now, I said clone. The right word might be snapshot, because in order to create a snapshot, I don't have to copy any data. I can basically say, it's sort of like creating this virtual volume where I didn't have to copy anything. And then as writes are made to the original, writes will be made to this virtual volume that I'm using, this snapshot.
You're right. For us, a snapshot is a point in time, and it's afterwards, that snapshot, all the future writes, they're copy on write. So from that perspective, it's very quick. It could be seconds to snapshot a terabyte volume, and you're not taking a new volume and copying the data. Yeah, that's right.
So it executes very, very quickly, which is important because we're running a pipeline here, and timeliness is one of the most important aspects of it. We're going to deploy this entire stack to a one-off environment with that live data so that we can run functional tests. And today I am going to be doing Selenium. I left out the JMeter, just, but it's to give you an idea of other things you could put in those functional tests. And then we'll deploy to production.
What are some other functional tests that people might use?
Pretty commonly, we see people like to do performance tests. They like to do the UI tests. Sometimes people will have even kind of a manual component where this pipeline will actually be staged out so that a ticket can be created and someone can go in and manually verify things. And sometimes they'll want to even show it to business owners. Other things, security testing actually comes under the functional test kind of umbrella. Sometimes we think of that as sort of like a static analysis that you would do beforehand. You can do that as well.
Yep.
But once you actually get things up and running, you can get sometimes a slightly different picture where maybe, if you're being secure, you shouldn't have changes to your containers after they go live, but you might be able to detect changes to your containers after they go live using some sort of security scan. So it really does run the gamut of what you might have under functional tests.
Very cool.
And then if those pass, we'll deploy to production and we'll remove the one-off environment. And this is a fairly simple pipeline, but under the covers, there's actually some really interesting things going on. For example, our application, again, it's made up of all of these different images. I don't have to build the Redis image, and I don't have to build the Postgres image because I'm just using the default. But my Python, Node, and .NET images are all in this single mono repo. So I'm actually going to build them every time that I make a change so that I know that everything works together. And it's nice because it keeps basically my commit SHA and kind of identifier in line with what's running so that there is parity between them. And this makes your life a little bit easier when it comes to debugging or doing rollbacks or those kinds of things. And so we're going to build those in parallel. So we're not going to be linearly waiting for them each to build. So we'll jump into that and we'll do some demo action here. So with that, let me switch the screen share here. Give me just a second. See what's on my screen. Good. All right, so I'm now sharing my screen and, I can't see it on here. I want to see it on here. Okay, all right, so you should be looking at a moon man mowing his Kubernetes lawn. All right, so I'm going to jump into CodeFresh here, and we'll kick off this change. We'll look at our application. Let me give you just the briefest of tours to CodeFresh. This is a view of all the repositories I have connected. This is the example voting app that I talked about earlier, so we're going to drill into that. You can see there's a section for looking at all the builds that I have. there's a built-in Docker registry. So all of my images are here with all of their metadata. And then we have a Kubernetes integration where I can see all of my connected clusters, what services are currently running, and I can also look at my Helm releases. So for example, let me look at the cluster we're going to work with today, which is this demo cluster. You can see there's this prod voting app. This is what we're going to be using. And if I dig into that, we can see the services that are currently running. We can look at the application, and this is the best way to look at an application probably is to actually look at the application. So you can see I was at, let's look at sorry, there it is. All right, so here's the app. I can basically vote if I like cats or dogs better. And I'm a dog person myself, and anybody who says different is wrong. And you can see I added this message here that says, "Hi Sauce Labs," because last night I was presenting this at Sauce Labs. So I don't think it's appropriate for this demo, so I want to remove it.
Sure.
That'll be the change we make in our pipeline. And then here's the results, and we saw that actually just changed in real time. So anybody that's enterprising and wants to go to these IP addresses can vote, and we'll see the state change. So right now we're at 17 votes. And if we can remember that, we will see that in the snapshots of the application that we do. So just another point of order while I'm here, I can see all of the releases that I've done to this chart, and I can actually issue rollbacks. So if I had detected an issue and I didn't know what it was and it was a serious issue, I could execute the rollback immediately and then go and dig into exactly what had happened, who had done what, and issue my change and roll forward.
This is all the declarative, powered by the declarative.
Yeah, yes, exactly. And so these are actually Helm packages. These are the Helm charts that are versioned automatically here. I can see my Helm chart with all of the associated kind of underlying charts, such as these Postgres ones, and the values that I passed in. So there's a lot of kind of tooling here to help me work with Kubernetes and Helm. And so what I'll do is I'll kick off that change, and maybe let me just close a bunch of these tabs so that I don't get lost. We'll make a change here. Oh, and it looks like somebody was enterprising and went and made a vote. Good on you, viewers. We're going to make a change. We'll kick off the pipeline, and then I'll dig into that pipeline and what it's actually doing. And just to familiarize you with two different views here, this is where I'm going to make my change. And then I have this monitoring here going, but because things are going to happen very quickly, and it's going to be easy to get lost. And this will show us how fast we bring up the staging, and then how fast it's torn down. Okay, so let's go ahead and make our change to our application. And this is to the voting app, and I had added this Hi Sauce Labs. Highly inappropriate for this webinar. We gotta get rid of it. Gotta get rid of its stat. Okay, so let's write that. And we will push it. And before I click push, I'm just going to go to my repository and the builds that are associated with it, because we'll see that it kicks off here. So I'll commit that, and we'll see this kick off within a few seconds. There it goes. All right, so the first thing it's going to do again is it's going to clone all of the code from this repository with all these different applications in it. And then it's going to kick off a matrix build. And so the matrix build will actually say, I want to build 3 images at once. And so we'll see 3 different pipelines kick off. See, it's got this check build concurrency. What it does is it checks to make sure that it doesn't need to rebuild them. And now those 3 extra pipelines have been kicked off to fire off all those Docker builds at once. Now, if we drill down into this, what I'll explain is that each of these steps actually occurs inside of their own container. And from a pipeline perspective, this is actually really critical, because it means that I can pass information between each container. Or let me back up, sorry. running each step inside of its own container basically means that I can have different versions, different software, sort of a different stack almost inside of every step. So I could have a ton of flexibility, but all of these steps are going to be connected by a data volume so I can pass information between them. So again, the service we're working with had those sort of 5 different microservices. I need to build 3 of them because there are 3 of them that are inside of my repository when I make a change. So it's going to build that, and it's going to, here it created the volume snapshot. That volume snapshot took 10 seconds. So it was incredibly fast. It deployed the chart to staging, and now it's going to wait for the endpoint to be ready. This is basically waiting for an IP address. We could speed this up by setting a default ingress.
Sure.
Then we won't have to wait for it. But this gives me a chance to jump over and show, here's where all of the workers have come up for the staging instance. This one, when it first came up, the Postgres wasn't ready, so it errored out, restarted, and now it's working. So we're now fully functional on this. Once the IP address becomes available, we'll kick off the functional testing, and we'll actually be able to view the change in staging and the data associated with it. So we're going to wait for that endpoint. Sometimes it takes upwards of a minute. So this is a good time to take a little bit of a breather, give you a chance to ask some more questions, get those Q&A in there. And I sense that there's going to be some questions about why we had 3 different builds. I saw that there was a question in there. So
yeah,
we'll catch up with that maybe at the end. Any thoughts so far? The snapshot thing that is really impressive.
Actually, could you show how the snapshots were taken?
Oh yeah, let's go. We'll show those. Oh, before we do that, it's going to build the test image for Selenium here, and we can pull up the endpoint to actually look at the application. It's hard to look at because it gets torn down automatically, and it happens very quickly. So it'll move fast. It built the tests, and now it's going to run those functional tests where it's actually going to it's actually going to send out to Sauce Labs, basically to kick off a Selenium grid to go through and do all this stuff.
Cool.
And then, to show how these snapshots were created, what's really cool to me about working with Portworx, this is the snapshot, is that there's not some special API, there's not some sort of special tool you need to use. All I'm doing is pushing Kubernetes configuration that says, make me a snapshot.
That's right.
And then we're pushing a Kubernetes configuration that says, attach that snapshot to this volume. And then when we get to this deploy to staging, we're saying there's a volume that's already been created, just attach to that. You don't need to create a new one or worry about it. Just attach to the one that exists. All right. So it looks like the tests ran successfully. Here's that cats versus dogs, and it's going to be torn down now within, you can see it's actually tearing down. It's finishing the update of production where it's terminating the old ones. It's doing that rolling update. And then we'll see now it's pulling down the staging for us. So we'll be back to the original state that we started with, and we tested with that live data. So we knew we had this sort of high degree of confidence that what we tested is exactly like production. And this instance now will be gone, won't answer, and we'll come back to our new instance. Oh yeah, I don't want to resubmit. And we'll see that the message is gone here that I had added. So we're now completely done with our rollout. And if this were a live event, this is the moment where I would wait for everyone to applause. I assume that you're doing it at home. I assume that you're just going crazy wherever you are. Oh my gosh, it totally works. It does, it totally works. And that whole pipeline was 4.5 minutes, and it blows my mind because I made a snapshot of data. Like copying data, like it always slows things down. It's always like the oh my gosh, I got to wait for all this stuff to read. But that was the fastest part, and it was there were actually a number of things that I could do to make this pipeline even faster. Not having to wait for the endpoint and having an ingress configured would be one thing. But part of the reasons that it's so fast is because I mentioned earlier that we attach this volume so we can pass data between containers in the pipeline. Well, we actually take a volume with caching and we reattach it to pipelines that have already run. So that means we can cache all of the layers and we can reattach them. And so the build process for these images is incredibly fast. And if we jump over and look at the builds, where we can see there was this change triggered 4 builds total. Each of those Docker images built within less than 40 seconds. So incredibly fast, and puts you in a really good position where, I mean, what we just showed, we could have 1,000 people come and start working and making changes at the same time, and we would have a high degree of confidence that this would scale to meet the demand. So,
well, the thing I like about the demo is that I think there's oftentimes bugs that you can only find when you test with live data or with real data. And so it could be things like corner cases, or the data is required to be reflected back in the UI. And so the idea here really is that taking things like integrations that we've done, you can now take CodeFresh and you can apply it to all your applications.
Yeah.
It can be part of the whole entire user pipeline that they're building. And so I think all this stuff is really cool. The fact that you have a SHA, you can click the SHA, go back to actual.
Yeah, so this is actually something I want to show really quick. Where should I show it? I can show it in here, that's fine. So if I go back and I look at my images, we can see these are the 4 images, the 3 images that we built for deployment, but there was also the test image. And if I drill on that, you can see there's a bunch of metadata that I've added to this for my own debugging purposes here. But I have a QA check that's set to true. I could pass in a URL where I could look at a report for how the UI testing went from Sauce Labs. I can also see who created it, and I can click on the commit SHA and see any of the changes that were made in order to prompt this change. Now, in this case, all 4 containers will share the same commit SHA because this is a mono repo setup. And so we can see the change that I made here. This becomes super useful when you get into looking at a production instance of an application and wondering, okay, something's wrong, but I can see that, all of my kind of Kubernetes statuses are green. What's the issue? Where did it come from? I can see the endpoint, and I can click on the image and I can get directly into that view where maybe there's, annotated information here, and I can drill down directly to the commit SHA, see what happened. I can actually see the entire pipeline that occurred in order to create this individual image, as well as sort of drill back to sort of that sort of parent pipeline if I need to. And I can also see all the layers. This is useful just for optimizing your Docker images. So there's definitely a ton of stuff here, and I could spend a long time going through the nuances of like, oh, this is how you share a configuration, this is how you encrypt variables, all that stuff that's very interesting, but not the purpose of today's meeting. So with all of that, let me jump back into the presentation mode, and then I think that we'll be ready to take some questions. So here we go. All right, now that's question time. So one thing that I'll mention just verbally is at codefresh.io, we do have a $500 GKE credit.
Great.
So if you want to try using CodeFresh and you need some credits to get a cluster up and running, we can help you out there, and feel free to schedule a one-on-one with us. And then, of course, Portworx is actually very easy to set up with GKE, which is kind of a prerequisite for the demo that we did today. But
we'll send out a link that has how to install on GKE, because from that perspective, it just deploys as a daemon set. So not just a snapshot, but the whole entire integration and deployment experience is integrated so that we sit on top of instance groups and take advantage of everything in Google.
Great.
And so, yeah.
So I see that there are a couple of questions. There's one on PII, which I'll let you take, but the question on why does it kick off 3 builds at the same time? Which is a great question. If you remember our application, it's this 5 container stack, right? And my voting app, my result app, and my worker are all using a mono repo. And so I'm actually going to build all 3 images when I make a change, because there's a little bit of split opinion about this. I like to have my images always match my commit SHA. And this is sort of a GitOps principle where you basically say that your images should always match your commit shot, because it means that you can basically go to a commit and roll back, and you basically have parity between your Helm status and your repo status and your image status. And it keeps things very organized, and especially in a high volume environment, it's nice. And so the reason I kick off 3 builds at once is because I don't want to do it linearly. I don't want to build one container, wait for that to be done, build the next container. I want to build all 3 at the same time, because it will save me some time when I run that pipeline. So hopefully that answers the question. Feel free to elaborate more if you'd like me to dig into it more. And then there was a question about how do you handle PII when snapshotting the production data into the staging environment?
Yeah, so I'll say a couple of things. One is this PII can be extended to PCI or HIPAA. And from our perspective, the key thing is that there are protections that you have in place. In Kubernetes, there'll be namespaces, and you can think of a namespace as a way to say a project in OpenShift, or a way to say that this group has this privileges to these set of volumes, if you will. And so from our perspective, this is really a way to say that if I think about the full scenario, in high availability, if I have a server fail and I want to be able to kick off another server, or kick off another Postgres instance on another server, it's the same privilege, or it's the same application that's getting serviced. So from that perspective, it's not going from a trusted to an untrusted. So that's a high availability answer. And then to this specific question, it becomes, if I have PII and I want to protect that data, the encryption is more at the infrastructure level. It's more that this workflow is more about how do I ensure that the next version in time, or the next version in time, is also correctly tested and giving it live data. So from that perspective, this is not a way to change who has ownership. This is a way for the people that have the rights to it to actually verify that the next version will be correct. After that, it does become questions of how do we ensure that the namespaces are always part of the whole flow, and that when I'm moving across clusters as well, that the namespaces are preserved, and that's something that we do. So it's not meant to be an escape hatch. It's meant to say that trusted and trusted get to continue using their data and test with Stateful, or fail over with Stateful, if you will. In terms of just changing the privileges, and that's something that is more about how do I change the namespacing. And so that's a separate topic, and we can always follow up on that.
Yeah, and I think the key element on this particular demo, we are not changing security levels. We actually stay in the same cluster, same namespace even for what we deployed. And you can think of it like a blue-green deployment, where I now have a copy of my application running in production. It has the same level of security as what's production, because it is it's about to be production basically. So it's not a true blue-green deployment in the sense that we're just changing the networking at the end of the day, but that's kind of what's happening. Now, if you are going to move to a separate cluster where people have different data privileges and people might be able to access that, then you would need to worry about having a step where you potentially filter data or maybe even load in dummy data in some cases. But that's sort of, that would basically be taking what's been done here and adding a step in between.
So there's a couple of things. It's exactly like you said in terms of filtering and control process. One thing is, because our volumes are encrypted, if you don't have the encryption key on the other side, then you wouldn't be able to mount the data. So that's just part of the answer, and that goes especially into the PCI, a little different than PII as well. But those things can be set up around as well. Mm-hmm.
Yeah, great question. So, and then another question that I've seen here is, how do you feel? How often do you see people running with Stateful in production? Because there are some people who kind of feel like, well, this is new. Is it really ready for prime time? Do you feel like people can deploy with a high degree of confidence that, yeah, running Stateful applications on Kubernetes is not an issue?
Yeah, I think some of that gets to both the journey and the skill set. I would say that time and market, it's actually been around for quite some time. So it is true that if you look at just recently how many other vendors are deciding to standardize on Kubernetes, that's a great thing because the user experience is unified and it's also the best scheduler. But from that perspective, that works. But at the same time, people have been doing this for quite some time. Examples is there's video companies that we work with that have been using Kubernetes since 1.0, which is now 2-3 years ago.
Wow.
The other part here is that—
in production too.
In production. And I would say that our customer base 70% is in production, in the sense that that's how they come to us. And the last 30%, it's time to get there. I also see the flip side, where I've seen other companies say, how do I ensure that my Kubernetes is my competitive advantage? And I don't know that that's a harder question to answer, but my comment here is, there are people who are doing it now. There are people who are also saying they're doing it now, and they're using it as a way to have this faster process, this more agility, and they're seeing it as part of their competitive advantage. So over time, I think it'll come to the masses. It is true that I think there is an evolution between, I'm going to do it with containers, then I'm going to do it with my scheduler, then I'm going to do it stateful, and that's happening and scaling now. And so if I, even including the examples, I'll take a double check, but those customers that I included here are all in production.
Yeah, great question. Yeah, great answer. Here's another question. Is the approach of having a single repo building all images scalable when you get to 20 or more containers? If not, how would you handle this better? The truth is that today, I don't think we at CodeFresh have a really great answer for how to solve this. Now, monorepo is something that's in use kind of famously at Google and Microsoft. And Google has built a staggering amount of tools to make monorepo work. And it's one of the things I always hear from engineers when they first leave Google, is they're kind of on the Google high of like, oh, I'm an amazing engineer. I worked in like this amazing cloud company. And they leave Google and they're like, oh no, where are all my tools? Because there's so much specialized software there. And there's a lot of work that they do that I think we're going to try to sort of expose to the masses here. And so today the best answer is basically to use a branching naming strategy where your naming conventions are dictating what's getting built. It's not perfect by any means. But it does put you in a situation where you can get some of that efficiency of well, I'm only going to build the images that I need to build. And in terms of scalable, like building 20 containers or 100 containers, the building 1,000 containers at the same time isn't a challenge for us. Right. That's fine. We don't care if you want to do that. Whether or not that's within budget to do that is a separate question. So it kind of depends on your needs. It kind of depends on the size of your organization. And I would be really happy to have a one-on-one conversation about what you guys are doing and how you'd like to fit in. So anyway, we're going to go ahead and wrap this up. I think we'll do just one last question for you, Eric, which is dealing with multiple availability zones and just how you think about that from a stateful perspective.
Yeah, I think it's a requirement. And so availability zones and racks are almost interchangeable. And so I don't want a rack to go down to cause a data loss. I don't want an availability zone. And so in the cloud, it's actually very straightforward. You can curl the metadata server. It'll tell you the zone placement. And that's what we do in AWS, Google. And so from that perspective, you'll know what the availability zone is. And then we use that to inform our replication so that the application replication is across availability zones or across racks. And oftentimes it matters because these super large companies that deploy physical data centers, their teams don't have dictate over where the contiguous racks are going. And so you have to be able to span these topologies. But yeah, this is, by the way, before we end, this has been awesome to work with you, Dan. And
thank you.
CodeFresh. So thanks to the CodeFresh team.
Yeah, thank you. I appreciate that. So, well, thank you everyone for joining in, and we really appreciate asking all your questions. Feel free to reach out to us individually, one-on-one. Both on Twitter or through our website. We're happy to have follow-up conversations, and I know that you're very active speaking. I'm heading to Redis conference this afternoon to speak on the same subject. So if you want to replay beyond the one that we will send out to all of you, come to wherever we're speaking, and you can find our schedules online. So thank you. And with that, we will end the webinar and see you all soon.